So in this video we will see about variable reluctance type transducer, and this type of transducer are forerunners for LVDT that we will be seeing in the preceding slides. So in the here is a variable that consists of a same the ferromagnetic core, and this ferromagnetic core is surrounded by the coil, and this iron, something a similar iron is placed over the ferromagnetic core, but it does not touches it. Okay, so this movable iron will be moving up and down based on the displacement that produces the movement. Target does not touch the physical contact with the core, and which is with the coil is mounted the core and the target, because there should be air gap. I will tell you the interpretation of importance of the air gap, because that air gap is going to produce the reluctance in the magnetic in the setup. Okay, so the reluctance of the magnetic field, and you know that the reluctance of the magnetic field is directly proportional to change in the self inductance of the coil. So what we will be doing is we will formulate that there are two types of reluctance on the magnetic circuit, that is n squared by r. The r can be decomposed reluctance of the iron path and reluctance of the reluctance of the iron part and reluctance of the air gap. So and the iron part is negligible, and when compared to the air part. Okay, so so what is the reluctance? When the induced EMF is produced, there is an opposition, the magnetomotive force that opposes the flux. The magnetomotive force that opposes the flux inducing it is called reluctance. That reluctance air gap is more. Okay, when compared to that of the iron rod, so that is can be written as n squared by rg, which in turn lg by mu 0 ag. Okay, and all these are constants. Then what you can you substitute all this here, then L is inversely proportional to Ig. So when I am changing the length of the air gap, when the air gap increases, what happens? Inductance reduces, and when the inductance is reduced, there is an EMF induced in the coil, and that